Okay, this is lesson 1.2. We're talking about perfect square roots. So we're talking about perfect squares. We actually have to go back and talk about one-dimensional, two-dimensional, three-dimensional objects. So this is what we're going to talk about. So if we have a one-dimensional object, we're measuring one thing. So if I said to you go measure the length of this room, you're measuring one thing, length. And that is a straight line. So whenever you have a straight line, it's one-dimensional. So if you take a look on centimeters, remember, everything has a hidden exponent 1. So there's a hidden exponent 1 on that centimeters. This little hidden 1 tells you the number of dimensions were measured. So if that's a hidden 1, that means we measured one dimension length. Okay? Now if we take a look at exponent 2 is area. Well, that's our squared side. We always deal with square. So we see the squared sign here, and that means we've measured two things. We've measured length and width, or sometimes it's called base and height. Okay? So those are the important things about knowing one-dimensional objects and two-dimensional objects. Then we talk about volume. Volume is for three-dimensional objects. Now, the big thing about volume is if we're talking about 3D objects, volume is always the area of the base times the height of the object. They are always named by the base. So if I've got an object that looks like this, a pop can, that's a cylinder. The area of the base is a circle, so it's a cylinder. That's why the area of your base is in the volume of a circle. Okay? It'll include the volume. Volume will include the circle, being the area, pardon me. Got a little tongue-tied there. Alright, so volume includes area of your base. If I have a triangular prism, that means my base is a triangle, and then so is my top is a triangle. Okay? Now these triangle bases, they might flip them over and they actually might be sitting on one of the rectangle sides. That's okay, but remember, there's always two of the same object. That's what they name their bases by. Okay, there's two of them. Okay, if it is a cube, all the sides are the same. So for a cube, there are 6 sides that are identical. And what we measure for volume is area of our base. Well, area of our base would be length and width. And then you got to multiply it by the height. Well, if it's a cube, that means all of those are the same number. They're the same length. So we can easily say length times width times height, or we could say volume is side cubed. 3 of the same sides. Okay? Again, volume, the units are cubed on purpose. That 3 means that we measured 3 dimensions. Length, width, and height. Okay? So we have 1D objects, 2D objects, and 3D objects. And these are super important for us to know because when we start talking about perfect squares means we've got an area of a square. Okay? And that's where we're going to go next. I'll just give you a moment to write that down. Push pause down and play when you're ready. Okay, continuing with our lesson on perfect squares. So we're talking about square roots and perfect squares. Now, if I want to know the definition of a perfect square, it says it's a number with a rational square root. What that also means is, it is a number with 2 identical factors. Okay? That's what it is. It is a number with 2 identical factors. So, 2 times 2. 2 and 2 are identical factors. They will give us a perfect square of 4. So the factors are identical. So whenever we see identical factors, and there's 2 of them, that's why the exponents on all of these are 2. So what do you think that 2 is actually doing? It's got a job. It's doing something. What is that 2 doing? Okay, it's squaring the number. But what do we mean by that? It's squaring it.
The number times itself.
Beautiful. So it is the number times itself. So it's telling us how many times to take that base number and multiply it. So if that number was a 7 as an exponent, you take your base number and you multiply it by itself 7 times. But we want squared. So it's saying take the base and multiply it by itself 2 times. So that's why we get over here 2 times 2 is 4. Okay, there's 2 2's. Over here we're going to get 17 times 17. 2 identical factors. Okay, that's why it's squared. All right, we've got the perfect squares from 1 all the way to 25 squared. So 25 times 25 is 625. Do you notice any patterns in the numbers? We just look straight across. Do you notice any patterns on the numbers? Look at the digits. Look at the factor digits. 1, 6. 1, 1. 1, 6. 2, 1. Interesting. So what do you think the next one will be? 2, 6, right? How come? Because here I've got a 1, 1, then we went 2 first, then a 1. Then it'd be a different number. Then you're going to go 3 and then a 1, right? Okay, let's take a look at the next one. We've got 2, 7, 12, 17. Are you noticing anything with those numbers?
It's going up on 5 again.
It's going up by 5, but there's lots of 2's and 7's everywhere, isn't it? Okay, 2's and 7's. The next one, what are you noticing? What kinds of numbers do you notice? 8's and 3's. Okay, so there are patterns to the numbers. And what you notice is, if I were to take the numbers, and if I go 2 squared is 4, 3 squared is 9, 4 squared is 16. If I actually see how much they're adding every time, here they're adding 5, here they add 7. What do you think they add the next time? 9. It's every odd number. If you add an odd number to a perfect square, it gets you to the next perfect square. So the next number would be plus 9. That's going to give us 25. What's the next odd number after 9? 11. So if I add 11, let's see what happens. 36, another perfect square. What's after 11 for odd numbers? 13. So if I add 13, I'm going to get to 49. Pretty cool pattern, hey? So hopefully in numeracy you identified some different pattern type things like these. These are specific patterns with perfect squares, okay? So these patterns are going to help us on our non-calculator portion. So make sure you write these little mental notes down, okay? Because we do have a non-calculator portion of our exam, okay? So perfect squares, pattern. Well, add consecutive odd numbers to each perfect square equals the next perfect square. I'm writing between here in blue. Okay. I'm going to erase the red just so you just know the blue's there. Alright, so next. So every time you add a consecutive odd number, and remember, consecutive matters. Consecutive means in a row. So you're starting with odd numbers of plus 3, plus 5, plus 7, plus 9, etc. Okay, so those are the patterns you're adding to each perfect square. Okay, I'll give you a moment to write that down. So as we can see, everything in math has an opposite function. So if I take a look, we're talking about squaring things. The undoing of a squaring process is finding the square root. So they are opposite functions. And I'm going to show you exactly what that means. So if I have, example, if I have 5 squared equals 25. If I want to get rid of that root, that squared sign, I need to take the square root. So watch what happens. That means I square root both sides. So I'm going to square root 5 squared, and it's going to be equal to 25 square rooted. The reason is because on the right-hand side, there's no opposite functions, so I have to solve it. So that's going to give me a 5. But in order for this equation to work, I need the left side of my equation to equal the right side. Well, if I got 5 on the right side, I need to get a 5 on the left side to see what I started with. Well, a squared sign and a square root sign are going to cancel each other out. You literally draw them as a cancel. So what's left over is the 5. That works with every perfect square. So if I take the perfect square of, let's say, well, I'll just say 169, and that's going to equal the square root of 13 squared. They cancel. The answer of this guy is 13. Okay? So this guy equals 13, and my right side equals 13. Okay? So again, we just cancel the opposite functions. So just like adding has an opposite of subtracting, dividing has an opposite, which is multiplying, well, squaring has an opposite, which is square rooting. So what do you think for cubing something? What would be the opposite of cubing? You cube root it. So if I have 5 cubed equals 125, if I want to find the cube root, I do this. So 5 cubed, I now put on what's called the cube root sign. So all that happens is you put a radical sign, but remember, with a normal square root, the index over here is a hidden 2. It's a hiding 2. That index says that 2 numbers multiplied give you the number underneath. That's what that index is telling you. So now, since this index here, I need an index that matches my cube sign. So it's going to be a cube. This index tells me that I multiplied 5 3 times to get this number. That's what it's telling me. So these are opposite functions. They will cancel. So you're going to get 5 is equal to 5, because the cube root of 125 is 5. Okay? So we're just doing backwards. Okay? So let's try it again with a square root. So we're going to take another example of a perfect square. So I'm going to take 49, right down here in our booklet. So if I go square root 49, remember what you do one side, you have to do the other side. So I'm going to square root that guy. Well, what happens to the 7 on the right-hand side? We cancel out both sides. We cancel the square and the square root. And what do we notice the answer of root 49 is? 7. So now we get 7 equals 7. Okay? And that's how those work. 7 equals 7. Okay? So, opposite functions. Again, squaring, square rooting. Cubing, cube rooting. Adding, subtracting, just opposites. Okay? Alright. So if we take a look, that's going to help us when we're talking about our dimensional objects and when we put it into problem-solving questions like volume and area. So we're going to go into some questions on volume and area. So here's our first question. If I want to find, so question 1, find the area of a square with a side of 2.5 centimeters. So what would you do to solve that question? What is the strategy to solve that question?
Just times 2.5.
Times it by 2? Is that 2 squared?
If you find the area, you have to cube that.
So close. Starts with S. Square it. Yeah, you were so close. Yeah, so remember, it's a perfect square, so we have the side length, and what I like to do is I like to draw and label. So I've got a square, these little dashes mean that each side is the same length. That's how we know it's a square. So I have a square, side length is 2.5. Well, I'm just going to label 2.5 everywhere. All right. If I want the area of a square, I need to take length times width. Well, it just so happens that the length and the width are the same number. For the same number, you can just say side squared. Okay, because it means you need two of the same number, because they're identical size. So now we're going to say it's 2.5 squared. So how big is 2.5 squared? Practice on your calculator, please. Okay, so we found the answer is 6.25. And if that's centimeters, that's now going to be centimeters squared. Remember your units, because this tells us that we took two measurements, length times width. Just so happen they're the same size. Okay, so that's the one type of question we're going to get. So we're going to get an area question about our rectangle. It's going to give us the side length. Well, what if they give us the area and we want to find the side length? Well, it's just working backwards from here. So, example 2 is going to be find the side length of a square garden that is, let's go with 3.24 meters squared. So find the side length of a square garden that has an area of 3.24 meters squared. So I'll let you write that down, and then we're going to talk about strategies to solve it. Okay, so area is equal to side squared for our garden. We know that it's 3.24 equals side squared. So whenever we've got a squared, if we want to undo a squared, we need to square root to undo the squared sign. So remember, if we undo that squared sign, these now cancel. And that gives us our side length of one side of our garden is equal to how big?
1.8
1.8
meters.
So 1.8 meters. Okay? So the side length is 1.8 meters. Okay. It is a small garden. It's only 1.8 of these. That's all. All right, let's take a look at another couple examples here. Number 3. A rectangle is twice as long as it is wide. With an area of 288 centimeters squared. Determine the length and width. Length and width of that rectangle. Okay, I'm going to write the next question down so that we can write all our questions down, and then we'll go back and we'll solve it, okay? So, number 4. Rectangle way. This. These are reviewed. Oh yeah, that's good. Yeah. Oh, it's always unit 2 and 3. So unit that pattern is always unit 2 and 5. So number 4 says a rectangle has a length 75% longer than the width. I'm just going to move it up a bit. Is that too high up? Is that too far? Let me know. Yeah, these people extra practice and this A rectangle has a length 75% longer than the width. And an area of 448 centimeters squared. Determine the length and width. Okay, so we'll write that question down, we'll write a couple more questions down, and we're going to solve them all. Did I move it up too high? Too fast? Let me know if I'm going too fast, please do, okay? Because I really, I'm a big geek, I love math, so when I get excited about stuff I really like, I end up talking faster, and then I go faster, and I like this stuff, so just slow me down if I get too excited. It happens, sorry. Now we're going to put number 5 and 6 up there. I'm going to keep you together stacked up grade 11 stuff. It's right here. Look at the practice bookets at the end of the practice booklet section. Really? Oh, hang on, let's reset this guy. Looks like something's going on with it. So let's see if that works. Yeah, that worked. Okay, can I write the next couple questions? Are we done with that one? I'm motoring. Let me know. 5. A right triangle is made by cutting a diagonal on a rectangle. With an area of 338 meters squared. Okay, so that's the rectangle's area. What is the perimeter? Sorry, this is the area of the triangle area. Triangle area is 338. What is the perimeter of the original rectangle? So that's another question. Okay, back to our questions. We've got a couple minutes to write them down. So when we take a look at the first one, always draw a diagram to represent what they're talking about. So we've got a rectangle, and it says it's 2 times longer than it is wide. Well, we don't know how wide it is, so we're going to label the length W. And if the width W, but it says it's 2 times longer. So I'm going to put 2W for the length, because it's 2 times longer than the width. Okay? So those are the dimensions right now on our diagram. The area of this rectangle is 288. Okay, so that's the information we know. So now we set up our equation. We say area of our rectangle is length times width. And then we plug the numbers in. So, well, area is going to be 288. My length is 2W. My width is W. Now, this is a concept we haven't covered yet, but I'm going to show you a little trick. So when we multiply variable times variable, we actually just count how many variables there are, and we add their little hidden exponent. There's a little hidden exponent on the top right, always, always. If you don't see one, there's always a hidden one. So this guy, when we multiply on the right-hand side, that's going to end up becoming 2W squared. And now we're down to a 2-step question. Now, there's a number sitting in front of our x squared, or W squared. Whenever something is sitting side by side, that means multiply. So if it means multiply, I need to get the W by itself. How can I get rid of a positive 2 that's being multiplied? Remember we talked about opposite functions. Opposite functions get rid of things. So you divide it, good. So if we divide out the 2 to the right side, we've got to divide out 2 to the left side. So if we divide 2, we're going to get 144 equals W squared. Okay? So now we're back to a perfect square. And how do we find our answer if we know something is squared? How do we undo a squared? Square root. Good. Yes. So we are going to square root 144 and square root W squared. And as we see, those cancel. So that's going to give us W equals, how big is root 20 or 144? 12. Great. So that only tells us our width. It wants to know the width and the length. So what we do is we go back to our diagram and we say, okay, the width we found is 12. Well, the length is 2 times as big. So 2 times 12 is going to be the length. How big is the length? 24. Good. So we would say the width equals 12 centimeters and the length equals 24 centimeters. And that would be the final answer. So just solving the question isn't good enough. We have to actually find the answer of what it asked us. We need to have the dimensions of the rectangle. Okay, we'll give you a minute to write that down. Okay, next question. Number 4. A rectangle has a length 75% longer. This is when we have to get into using percentages changed to decimals. So how do I change a percentage to a decimal? You are correct, 0.75. How would you found that number?
75
Divide by 100. Take a look at what this is, guys. 1, 0, 0. So these are always out of 100, if you forget, okay? So you divide by 100, and we're going to get 0.75, okay? So, again, we're going to draw our diagram. So it says a rectangle has a length 75% longer than the width. So again, we don't know the width, he's W, but our length is W plus 0.75. Okay? Sorry, W times 0.75. No, plus, I got it. W plus 0.75. W. Okay. Good to go? All right. Now what we're going to do is we're going to take a look. On top here, if you don't see a number in front, it's a hidden 1. So how many W's do I actually have on top? Are there 2 W's? We have the numbers in front. So 1 and 0.75. So how many W's are actually here? 1.75 W's. So our length is 1.75 W. Okay? Now that's the crazy part. This is where the critical thinking happens. You have to realize that these each have to add. Now, when we take a look at those, we're going to say, okay, well, our area is 448. So we go back to our area equation for a rectangle. So area of a rectangle is length times width. So now we're going to put the numbers in. 448 equals length, 1.75 W, times width, which is W. So remember, what did we do when we multiplied variables? We added those little baby numbers on top, those exponent numbers. So we're going to get 1.75 W squared. Okay? And again, 448 is on the left-hand side. Now, we always want to isolate the variable. We want it by itself. So right now, something sitting beside it is being multiplied. And whenever we want to get rid of things, we have to do the opposite function. So what am I going to do? Divide. There we go. We're going to divide out the 175. Okay, that disappears from the right. And now on the left-hand side, we are going for the right-hand, no, the left, we're going to get 256 equals W squared. We're almost done the question. We need to solve for W. So how do I get rid of that squared side? Square root. You guys are on. So we're going to square root the right-hand side, so we're going to square root the left-hand side. That's going to get rid of our squared sign and our root sign. So we're going to get W equals 60. So now we found our length, or sorry, our width. We need to go back up to our diagram to find the length. So we say width is 16, and length is 1.75 times 16. So you have to take 16 and multiply by 1.75. So how big is our length? 1.75 times 16.
28.
It is so. So 28, and our units are, again, centimeters. Okay? All right, we're going to do, no, we are out of time. Okay, let's pause here. Okay, so this is the first round of lesson 1.2.